Welcome to today's webinar. The topic today is design of massive R-section sections in RFEM 6. My name is Andreas Hörold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, newsletters, and so on. I will be the moderator today and will answer your questions together with Alexander, but my two colleagues can introduce themselves.
Yes, hello everyone. My name is Paul Kieloch. I'm working at Dlubal in the field of product engineering, and there especially for the add-ons for concrete design. And in context to this, I'm happy to show you today new features in our section for definition of reinforcement and later on for design of this reinforced cross-section in our concrete design add-on in RFEM 6.
Hello, also from my side. My name is Alexander Meyerhofer. I'm responsible for the development of reinforced concrete design in RFEM, and also take care about the geotechnical analyze add-on in RFEM, and I will answer your question today together with Andreas.
Okay, thank you for your introduction. Then we can switch off our webcams so that the attendees can see the full screen. For the attendees who participate the first time, you can ask questions via this control panel on the right side of your screen. You can show it with that arrow and enter your question here, and we will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, at first, we will show you different options to define cross sections in our section. Means Paul will do that. Then he will define the reinforcement in our section. For the cross section that you see on the right side. Then Paul will import the section in RFEM 6, and then he will design the cross section in RFEM 6 with the help of the concrete design add-on. Okay, then I hand over the screen to Paul. Paul, it's your turn.
Okay, thanks Andreas for the introduction. And I can directly start with our standalone program or section. And I will create directly a new model for our section. So I'm entering here a model name. Let's just name it maybe our section and maybe 1, because I will show you multiple ways to define a section in this program. Then what's important now, if you would like to apply reinforcement on your section and do the concrete design, then you have to check on this option here, concrete reinforcement. And as you see now here, there appeared a new tab, reinforcement settings. And inside this tab, you can define the value for the concrete covering. It is set by default to 30 millimeters. And for our today's this example, I will leave it here with 30 millimeters. I just confirm it. And then we get this view here. So we have our navigator, we have our tables here and our graphical window. And now we can just use the options in our section to create any type of massive section. So I will start here at first in the first example with creation of a section by using lines. So therefore I will at first create here or modify the grid. So I'm open the settings for the grid and I will change it here, the grid point distance to 10 centimeters. So in this way, and then I can start with graphical input of the cross section. before I will do that, I can just tell you something about the materials. In this case, or in my case, the program has loaded 2 materials from my last file. So in this example, it fits already perfectly. So I need concrete material for the section and reinforcement material. If you do not find the proper material, then you can apply here material or create a material in the same way like you know it already from RFEM 6. So, as I said in the first example, I will just create here lines, boundary lines for a new section. So, for example, I can do it in this way. Just clicking here into these grid points and create a random section. It could look like this. And if these boundary lines were defined, then you can create here new parts. So basically, compared to the old program generation, there we had one program. It was shape thin for thin-walled cross sections and shape massive for massive sections. That 2 programs were now combined in one new program, that is RSECTION. So you find here both types, so the elements for line elements and also the parts if you would like to apply massive or create massive sections. We are dealing today with massive sections, so I will use now here these parts to fill these boundary lines with concrete material. Therefore, I can do a right click on this chapter here and select the option boundary lines. The program has already applied here the material number 1, and I can just graphically select these boundary lines, click on OK, and then we see our concrete section, our massive concrete section. And what we already see here too is these green lines here. That is basically our concrete covering, or the line of the concrete covering. That will be applied in the section as soon as you have activated this option for concrete reinforcement in the base data dialog. What you also see here are these blue dots. They will be automatically generated by the program. So that is basically an extension of this line, for example, and the program will generate here this blue dot. This blue dot can then be used for the stirrups to define the position of the stirrups. But I will come back to this later on. So at first, I will just show you 3 basic ways how to create sections here in our section. If you have entered such a section, then you can also modify it. For example, you can go here into these options here. In this toolbox, you find here an opening, for example, a rectangle opening. And if you would apply this one, for example, then the program would automatically generate here also this concrete covering line for this opening. That would be the way for the rectangle opening. If you would, for example, enter round or circular openings in a section, for example, to create an hollow core slab, then you can use this option. If I would apply here a circular opening, then the program would delete the concrete covering. That is caused because the program is in the current state not able to generate the concrete covering for arcs or circular parts. So therefore, we can make a short workaround for it. So I can divide this line, for example, by intermediate points. Maybe let's do it for 15 nodes. then it would look like this. And then we can switch to the table here with the lines, and you see here for the opening, the program has now applied here this line type arc. But if I click here on this cell and use the F8 key on the keyboard, then I can copy the item from the cell above and just apply it on this cell. So it would look like this, that I can click here through this table and change the arcs to polylines. And if I do it for the last line, then the program would be able again to generate this concrete covering line. So that is maybe a small workaround in the current state of our section. If you would like to apply openings inside a massive cross section, then you have to keep in mind that you cannot use currently arcs for it. Okay, that would be the first option. I will just save this file here, and then I close it and will show you the second option. A second option would be to use the file menu, go to import, and then you have here this option for a DXF file. Then I can select my DXF file here, click on open. And then in this dialog for the DXF file import options, I have to switch or mirror the z-axis in my example, and I will switch the dimensions to meter. Can confirm that with OK, and then I would get, for example, this section or this shape of a massive bridge cross section. Once again, these are just boundary lines, so there is no stiffness behind the lines. So I can once again go to my parts here, do a right click and say new part by boundary lines, select them and confirm it's OK and OK. Is, or what we now see is that our concrete covering lines are missing. That's because we have not activated the option concrete reinforcement in this file. So therefore I will just save the file here. And let's say our section 2 in this example, for example, here. Okay. And if I open the base data dialog for this file once again, then I can activate here this concrete reinforcement option. And for example, switch the or change the concrete covering to 55 millimeters, confirm that. And then we will see again our lines with the concrete covering, and again our blue dots here, our nodes, that are helpful for generation of these stirrups. So this is always just a extended line here from, for example, for this line. If we would extend this, then we would get this node and so on. Okay, that was the second way with import of DXF file. I will close this once again and create a new one, or section 3, for example. Check on this option once again. I leave the default value here. Now in this example here, it is important to check now the file for the project folder, because later on I will import this section into RFEM 6, and therefore it is required to make sure in which folder you save this file here. So be aware of in which project folder you create this new file. Okay. And the third way how you can create a new section is by using our cross-section library. So that is basically the same like in RFEM 6. You can just click here on this button with the cross-section library. Then you have here these massive sections. And for our today's example, I will use this cross section here. I will just modify the dimensions a little bit here, just by changing the expression or the name of this section, and it will automatically modify the shape of the section. So it looks like this. I can confirm that, and the cross section is created. Of course, I can now modify the section. I can also assign here openings, like I have demonstrated it in the first example, or modify here the edges or the corners of the section and so on. So you are pretty free in the way how you create the sections, and that is then a benefit to the regular cross-section library from RFEM 5. So you have here the option to import a regular section and then do user-defined modification on these sections. Okay. That are the three ways how you can import or create a section. And next topic would be to apply reinforcement on these sections. As I said before, by default, I have already here in my example the concrete material that is used by the section, and we have here our reinforcement material. And now you can find here in the data navigator these two options or entries, stirrups and bars. So stirrups is our shear reinforcement, and bars are the longitudinal reinforcement. It is the common way to apply at first the stirrups, and if we have applied the stirrups, the program will automatically generate points on which we can assign our longitudinal rebars on. So it is common to apply these stirrups at first. I will do so in this example too. So I'm creating a new stirrup. The program has already detected the concrete or reinforcing steel. It was selected here, and I can change the diameter of the stirrup to 10 millimeters in this example. And then we have to check the concrete cover points here. And for example, I can go here to this upper flange here, and I just select the nodes here on the corners of my stirrup, and now I have to be aware or take care of the nodes. I have to close the stirrup or the shear link by clicking a second time on this first node here, 514, so that the program knows that with the first and the last nodes with the same number, that the stirrup is closed in this way. And then it looks like this if I confirm it, and that would be our first stirrup here. I can do the same here for the web. So this point, this point, this point, and this point, and keep in mind, close the stirrup here by click on the first node once again. And then the stirrup is closed. And the last time here on this side, oh, I missed it. So here this one, this one, this one, and the 509 once again. And then it looks like this. Okay, I will save this. And the next topic is to enter here the longitudinal reinforcement. And therefore we use this option bars here. If I click here, do a right click on these bars, then I can apply new bars and to define reinforcement. At first, you find here definition type. by default, it is set to multi and uniform. So it looks like this, the rebar layout. Then we have also a variable where we can differ between the individual spacing, so distance between the individual bars. And then we have also options to define single bars. So I will use this option at first. So I will apply a single rebar here on a certain point. Therefore, the program asks me to enter a layer on which I will apply this rebars. In general, you could apply all rebars on one layer. So it would not be a big issue or problem if you would not take care about this layer system here. But later on, if we switch to RFEM 6, then we have to then you have the possibility to modify the length of the individual rebars on the member. So therefore, we will need later on the layer system, and I will show it afterwards if I have imported this section into RFEM. Therefore, I will create a new layer system here for this section. So the first will be reinforcement at the top side, then one on the bottom. Then I will create bottom additional, and the last one will be on sides. Okay, and that is my layer system for this today's example. And at first I will apply the reinforcement on the top side of this section. So now I can just click here on this button and define the position of the rebar, and that can be done by clicking, for example, on this node here, click on OK, and then the rebar was assigned here on this point. Another option would be click once again here on single, select this node here, and then I can stay here in this dialog and just click here on this button, apply and next, and then the program will stay here in this dialog, and I can just click on apply next, use the next position, this one, apply next, and that maybe on this position here, and okay, and then it looks like this. That would be the way how you can define individual single rebars inside your cross section. Next option here is to use the uniform layout. I will also apply it here at first in the top layer. Select, for example, these two nodes, this one and this one. Then the program shows me here the distance of the two rebars, and if I want to check it graphically before I assign it, then I can click here this button, and the program will show me here this graphic, how it would look like. For example, I can also modify it here and check how it would look like if I would apply 3 rebars, for example. And if it's okay, then I can click with OK and confirm that. And then we would have this here. And the next option here for entering these rebars would be that I can click here on this table or line in the table, do a right click and copy this row. If I do so, then I have copied these rebars here, so they have basically the same position, and I can just click into the table here and change the starting points here of this rebar number 6, maybe from that here to that node, and then it would look like this. So you can also use here this tables to modify the layout of your reinforcement inside the cross section. The next option would be multi and variable. There you have also to define a start and end point. in this example, maybe here and this one. But now I don't want to apply the rebar directly here in this position. I would like to apply it here, maybe on this position, and therefore I can use here the options with the axial distance of the bars from the start point and end point. So in this example, I would like to use 4 rebars with a diameter of 12 millimeter, and the first spacing should be 35 millimeters, and then 150 millimeters. Then it would look like this. I can double check it here by clicking on this button. It would look like this. It's okay for me here, and I can click on confirm, and then it looks like this. So that would be my top reinforcement here for this example, and I will switch now to the bottom reinforcement. That's basically the same like before. I just have to take care about the layers now. This time I will apply it here and use a diameter of 20 millimeters and confirm. And then I can click on this line here in the table, right click, copy row, and just modify here the start and end point. And then it's simple to copy here this reinforcement from one web to another. Next option I would like to show is to working with offsets. Therefore, I'm creating a new rebar once again. This time I'm using the start point, this and this one. Switch to 3 rebars. And if I click here on this button to check it in the graphic, then I would see that the spacing between layer number 1 and layer number 2 is maybe too close. And if I would like to change this here, then I can use this offset. In my example, I would like to use here 30 millimeters for the offset, and then it would look like this. Click on OK. And then these 3 rebars are assigned here. Once again, I can click here on copy row and just select these nodes. And then it looks like this. Now I missed here the setting for the layer system or for my entered layers, and this can be also checked afterwards. So you see here that I have applied the rebars number 10 and 11 into the wrong layer, so I can click here in this cell and put them into the additional reinforcement. Looks like this. Okay, and the last would be here the reinforcement on the sides. Therefore, I'm clicking here once again on new rebar, changing it this time to multi and variable. Select the start and end point. Start point should be here, end point should be here. The diameter should be 10 millimeter in this example. Offset is 0 now. I would like to apply 5 rebars. The distance from the start should be 0. The spacing is 15 centimeters, and the space or distance at the end and the last point is 8 centimeters. If I click here on this button, then you would see how this reinforcement would look like here in this example. I can click on confirm, and then it looks like this. And here I can do the same. Copy the row, just modify the start and end point. Copy. Start and end. And the last one, copy, start and end. And as before, I forgot to switch here the layer, so I will do it here in the table. That is our reinforcement on the sides. Okay, it looks good. So If you have entered all your rebars, then before you import this section into RFEM, it would be always good to check here this layer system. Okay, I save it. So this file is now named RSECTION 3. And I will import this file or this cross-section here now into RFEM 6 to do the concrete design analysis in or design checks in RFEM 6. RFEM 6 is already opened here on my PC. I will just create a new file, a new model. Now it's, as I said before, important to check in which project you will create this new RFEM 6 file. I will just say it's Beam. Then I'm switching to the add-ons. For sure, I will have to check on the concrete design add-on for this example. And in general, it doesn't really matter which annex I will use here for this example, but I will choose the German one here. That's okay so far. Confirm is okay. And then we have an empty file. Normal, in a regular way, if you would create a new section, then you would at first create your materials. But in this example, if we create a new R section or import a new R section, then we do not need to create new materials, because these materials will be automatically imported also by the our section file. So I can directly do a right click here on the sections, go to new section, to our library, and then I find here this button from our section. And if I click on this button, then you see here the small window, and now the program is searching for all my connected projects, and there I can go to RSECTION 3. That was the cross section which we have created now. I can click on OK. And you see our section here inside RFEM 6. I can confirm that. And if we open here the entries for the materials, then you see our concrete material that was used in our section, and also the reinforcement material that was used. And it is here not in black or in blue, it is in purple to show you that it is a generated item here. Okay, that is our section, and we can directly create a new beam by using this section. And in this example, just a very simple beam like this. Then I will apply here a support. Okay, and at the end, in this way. Okay, so the beam was entered, also the supports, and now I just have to take care about the loading and the combinations. Therefore, I will create a new load case with live load and change the action category here. So the program will automatically generate our load combinations. Confirm that, and now I apply here a self-weight of 3 kilonewtons per meter on member 1. Click on Apply Next. Then I switch here to live load and change to 15, and it should be also applied on member number 1. Confirm is OK. And then we have entered our loading, and I can switch to the combination 2, for example, and our loading would look like this here for the ultimate limit state, or for example for the serviceability, for example like this. Okay, I can save this, and basically I can directly start the calculation in the add-on. So the program will calculate the internal forces, and then start the design checks in the concrete design add-on. And it directly works out here in this way. Now we can do some modifications also on the reinforcement. So if I would like to change here something on the layout of the rebars inside the member, then I can open the member and switch through all these tabs here. For the concrete covering, for the regular sections, you would be able to define here these exposure clauses. For the imported R sections or R section cross sections, it is not possible. So there, the concrete covering was defined in R section, and you have just here this cell here with the information which concrete covering will be applied for the design checks. If you would like to change it, then you have to switch back to R section and change it in R section and import the cross section once again. For the shear reinforcement, the program has created one span, and by default the program would apply this layout from R section with a spacing of 30 centimeters. Of course, you can modify it here, the spacing, and you can also click here and copy this spans here. So for example, you will get 3 spans, then you could switch here the length of the individual spans and maybe say the middle span should start at 20% of the member length and go to 80% of the member length. And then you could switch here the spacing for the middle span, and then it would look like this, for example. So the shape of the stirrups or shear reinforcement was defined in R section, and the spacing can be afterwards modified in RFEM itself. So R section is just used for design or entering of the shape of the individual stirrups. Next topic would be the longitudinal reinforcement, and there you see here these items 1 to 4, and these items are generated by our layer system in our R section file. Like I said before, I have entered 4 layers in R section, and the program now creates 4 items. So for every layer from R section, you will get 1 item in RFEM. And now I can click on my 3rd item. So that was my additional reinforcement in the on the bottom side, and then I can change here the length of this additional reinforcement, and it should be, for example, go from 20% to 80%, and then it would look like this. So once again, where the reinforcement is exactly located inside the cross section is defined in R section, and after you have imported R section, the R section layout into RFEM, then you can modify the length of the individual items here. Okay, that's basically all we have to, or we can modify here in this dialog. I can confirm, then it looks like this here. And I can click once again on calculation, and the program will just do the calculation once again in the add-on. Then I will switch off the loading and also the rendering of the reinforcement and switch to the wireframe display model, and we can check the results. Okay, so what you currently get if you do a design check with R sections is the design check in concrete design UL 100. So it's basically general design check for sectional resistance. So basically for normal force, bending, and etc. Currently, the design checks for shear force and the Serviceability limit state design checks are not supported. We are working on a solution for it, but currently you have basically the same state like in the old program generation with shape massive. Yeah, but we are working on a solution for it so that we will have also in future the option to do shear force design checks and serviceability limit state design checks. So that is here my design check for the member, but I can switch also here to, yeah, for example, the required reinforcement on the bottom side and compare it with the provided reinforcement on the bottom side. And then it looks like this, and I can just increase the display factor here maybe a little bit. Then it looks like this. And then we see that our provided reinforcement is covering our required longitudinal reinforcement on the bottom side, just as a very simple example here on this section. If you would like to see further details from the design checks, then you can click here on this cell here in the table and open the design check details. Basically, there is the same like for regular cross sections in RFEM 6. You can also click here on the diagram in section and check here the concrete stresses and steel stresses, etc. In this example, it was now here for the X location by 2 meters. On that side where we do not have additional reinforcement, if I would like to show it for the additional reinforcement, then I can switch on the other side here and open it once again, and then you see here the stresses here in the additional reinforcement, for example. And what's also possible is to activate the interaction diagram. So you can click here on this option. If you have activated here this interaction diagram, then you get here this additional tab, interaction diagram. It looks like this for this example. And then you can switch here which interaction diagram you want to check or to see. My example is basically pretty simple, so it makes no sense to make here big changes because I have here just my from the loading in my example. But you see here the shape of the interaction diagram, for example, for my and n. And in this example, I can, for example, switch from the X location to without additional reinforcement and X location 2 on the right side with additional reinforcement here. You see it here. Oh, it was this one. So this one and this one. There you see how the shape of the interaction diagram is changing. That is caused by the change of the provided reinforcement. And if you would go here further into the middle of the beam by clicking on this keys here or these buttons, then you see here our acting moment. And if we go to the middle of the beam, it would be by 5 meters. And we have here our moment in this interaction diagram. And you can also check it here graphically here. So that is also a feature which you have in for the regular sections in RFEM 6, but it's also available for the user-defined massive cross sections from RSECTION. That is basically what's currently possible in our section in combination with RFEM 6. Like I said before, we are still in development, so that is the state, let's say, or let's name it summer 2023 or early fall 2023. As I said before, we are working also on solutions for the serviceability limit state and shear force design checks, and then you have also benefits compared to the old solution in a shape massive. That's basically all from my side now, and I would hand over the screen back to Andreas.
Okay, thank you, Paul, for this nice presentation. Yeah, maybe I hand over the screen to mine. Just a moment. Yeah, if you want to book your free product demonstration only for yourself, then just contact our sales team. You can scan the QR code or just click on that link in the PowerPoint presentation. You can download the PowerPoint presentation from our website. I will show you where you can find the presentation, the models, and the recording. Just a moment. Yeah, and you can also ask our sales team for a non-binding offer if you want. If you want to buy the program or any add-on, or for example, also a standalone program such as RSECTION. Okay, then I show you our website, dlubal.com, and then under news and events, you will find the webinars. That's today's webinar. The next week we present the webinar buckling analysis in RFEM 6. I will present it together with Dr. Jonas Bean. We share the webinar. I show the buckling analysis for shelves, and he will present the buckling analysis for plates. Okay, and also this webinar is online, an introduction to the interface to Grasshopper. So that's today's webinar. I click on it. You will get an email in the next days when the recording is online. Directly with a link to that page, as I mentioned. Then here you will find the recording in the middle. You can already find the presentation slides here, and if you scroll down, the models that Paul used for today. Okay, maybe a last wish or hint. When you leave the webinar, there's a small survey. It takes you only 1 minute. You can score the webinar. You can enter wishes for future webinars, for example, but you don't have to fill out your wishes. You can enter a sign such as minus or so. But it would be nice if you score the webinar. Okay, then thanks again, Paul, for this presentation. I thank you, all the attendees, for attending the webinar. Thank you, Alexander, for answering the questions. I wish all a nice rest of the day. I hope we meet each other in a future webinar, and I say bye-bye.
Ciao.
Bye.